Hi guys, this is me, Kong again from Posh coaching classes. Well, today our topic, if I may say, our topic today is differentiation. A lot of people from class 11th and class 12th, they face a lot of difficulties when it comes to differentiation and integration. But today we will talk about differentiation. I will give some examples as well. We will solve few questions as well so that we will understand how to solve differentiation. First of all, we should understand what exactly differentiation is. So just without wasting any time, I've just written a small definition of differentiation, what exactly it is. It says the rate of change of dependent variable with respect to independent variable is known as differentiation. Now, the two words which are coming here are dependent and independent. For example, if I want to make you understand about dependent and independent, you can take an example of your family. Your family has got your father, your mother, maybe you and your sister. So if we talk about father, he's a guy who works in an office, earns money, and then even in some places there are mothers who are also working, and then you have the kids. The kids are dependent on their parents. They are dependent for everything in the beginning. They require copies, they require pens, all the stuff for their education, all the stuff for their other extracurricular activities also, they are dependent on them. Now if we talk about mathematically, if I give you an example, for example, if we talk about area, it is length into breadth, or area of a circle. We say it is pi r squared, or volume, length into breadth into height. There are many more examples, but these are enough to make you understand what exactly dependent and independent are. See, here length and breadth, we have two entities, we have two things here. If we talk about length and breadth, they can be anything. They can be anything from 1 centimeter, 1 meter to anything. Even the same goes for the breadth. Breadth can be anything. So we call these two things independent. And what happens? If there is a change in the length and the breadth, this also changes. So this becomes dependent. So we have to understand that these are independent. Why? Because they can be anything. And this is dependent on these two things. That is the reason we call them dependent. Same goes with area of a circle. If we talk about this is radius. And radius can be anything. It can be in meters, in centimeters, and millimeters, but it can be anything. And the moment this changes, this also changes. This is anyways pi. We know that it is 22 upon 7 or 3.14. So leave this. We are talking about this. It is radius. It can be anything. So this changes. It makes a change here also. So what it means, that again this is dependent on the radius, and this becomes independent. Understanding my point? So same here, volume is dependent on all the three, length, breadth and height. Why? Because length, breadth, height, it can be anything. So the moment these three change, it changes the entire volume. If the length, breadth and height is lesser, we will get lesser volume. If it increases, even the volume increases. So these things become dependent, and they are dependent on the whatever it is on the right side. So right side makes a lot of difference. So if this increases, right side increases, we get the answer which is bigger. If this lessens, we get the answer lesser, right? So this is about dependent and independent. Now what we are talking about, the main topic is differentiation. So now what I'm saying, we are saying the rate of change of dependent variable with respect to independent variable. There is a change happening, and the change, the relation between the change makes it differentiation. So what we say, that differentiation is something where we are connecting, we are making a relation, that is with respect to dependent variable. Dependent and independent variable, these two things are very important in differentiation. So that's about it. Now let me rub this off and we will talk about few more things before going further in differentiation. So if I say differentiation, there are a few things which are must. First of all, delta. We call this is a triangular shape, delta. Now delta, what exactly this is? Delta is a small increment. Small increment. Again, I'll give you an example. If you take maybe a tumbler and it is full of water, and if the water is like, you can just, this is the tumbler, maybe this is 1 liter tumbler, and you take 10 ml of water out of the tumbler. It doesn't make much of a difference to this volume, so we call this a small increment or a small thing. This is not an increment, it's just a small thing which I'm denoting by delta. Now one more thing which you have to understand is d upon dx, and this is the symbol for differentiation. All right. So these things are few things which you need to remember before going further in differentiation. Now let us do a small question. Let us do a small part of a question. I'll just give you an example, and we are using the method. It is ab initio method. So in ab initio method, we use a particular set of things in which we solve the question. And for example, I'll take one question. If I say, I have a question, it says y is equal to f of x. This is just the general thing. I'll just give you an example how to solve questions. So whenever you have for example, this is y and it says y is equal to function of x. So now if we are to solve this, we can just make sure that we have all the things here, and then I'll just put it as number 1 here. Now what I'll say giving small increment to both sides. And I just now told you that when it comes to small increments, we show it with the delta. So y plus delta y is f of x plus delta x. This I will put as second. Now what I will do, I will subtract both. Subtract first and second. Y plus delta y minus y is equal to f of x plus delta x minus f of x. I think it's pretty much clear till now. So now this y and this y goes. Now I have delta y is equal to f x plus delta x minus f of x. Now we are talking about differentiation. So now for differentiation, I need a very important thing. So I'll just write it here. So what I will do, I will say dividing both sides by delta x. And why is it important? I'll just tell you in a moment. Delta y upon delta x is equal to 1 upon delta x, x plus delta x minus f of x. I think it's clear till now. So once that is done, I'll take this one, and before that I will apply limits. Applying limits to both sides. Limit delta x tends to 0, delta y upon delta x is equal to limit delta x tends to 0, 1 upon delta x, x plus delta x minus f of x. So what I did, this was the one, we just divided it with delta x. Now I am applying limits, because in differentiation limits are very important. We'll talk about that also. Now whenever you see this thing, limit delta x tends to 0, and the denominator is same, delta x here, delta x here, so this whole thing becomes dy upon dx. So to make it dy upon dx, we require limit, we require deltas, and this should be like this. And now what we will do, we will apply the limits this side as well. So this becomes 1 by delta x, x plus delta x minus f of x. This is dy upon, one second, dy upon dx is equal to x plus delta x minus f of x whole divided by delta x. So this is the expression. When we use ab initio method, we get this thing. Now one more thing you can do is, you can write d upon dx. Instead of y, you can write f of x is equal to x plus delta x minus f of x whole divided by delta x. This is one of the general methods how you can solve a differentiation question using ab initio method. Is that clear? So I'll just repeat it one more time. So what we have y is equal to f of x, that is function of x. We are giving small increment to both sides. Then what we did, we gave a small increment this side, because this is y, so increment will be in y. Here we have x, so the increment will be in x. So delta x, we are subtracting both. We have cancelled, one is positive y, the other one is negative, so we cancelled it. We got delta y is equal to f, x plus delta x minus f of x. Then we divided it with both the sides with delta x. What was the reason? Because we had to get this. So then after that we applied limits to both sides, and then we got the expression. Is that clear? So this finishes the first one. Now we'll go for the second one. We'll use the same ab initio method, and we will use the same set of format for the other questions as well. So if we talk about the syllabus of 11th class, we have two questions. For example, we have the first one. It says differentiation of sine x, and an important one. So differentiation of sine x, how we will do it? The same method we will apply. We'll write y is equal to sine x. This we will put as first. Then what was our next step? It was giving small increment to both sides. It becomes y plus delta y is equal to sine x plus delta x. We'll keep it second. Now we will subtract first and second. Now subtracting first and second, we are writing it y plus delta y minus y is equal to sine x plus delta x minus sine x. Y and y goes. We have delta y is equal to sine x plus delta x minus sine x. Till now, it is the same what we did in our earlier video. It was the same thing. We used it as first, whatever the question was given. Then we gave small increment. It was second. We subtracted first and second, and till now it is the same. Now, we will use few trigonometric formulas here. For example, if I consider this as A and this x as B, it becomes sine A minus sine B. So I will write, we know that sine A minus sine B is equal to sine A minus sine B is equal to twice cos A plus B upon 2 sine A minus B upon 2. So this is the formula. Sine A minus sine B is equal to twice cos A plus B upon 2 sine A minus B upon 2. So what it becomes? This is delta Y is equal to sine A minus sine B. So we have twice cos A. A is x plus delta x. X plus delta x. Then we have plus B. B is x upon 2. Then we have sine. That's what I'm writing. Sine A is x plus delta x minus B minus x upon 2. Straight till now. So now this x and this x will go. So what is there left? It is twice cos. It becomes 2x plus delta x upon 2. Then we have sine delta x upon 2. So this is part 2. That means we have used the formula, and till the time we could go further, we have just gone. Now what is left? The leftover thing is delta x, because we have delta y, we don't have delta x. So what we will do? We will divide both sides by delta x. So it becomes delta y upon delta x is equal to 1 upon delta x twice cos 2x upon 2 plus delta x upon 2 sine delta x upon 2. Don't get confused here. I have not done anything here. It's just a simple thing. This 2 is with this 2x as well as with this delta x. So what I did, I just bifurcated it. It is 2x upon 2 plus delta x upon 2. Why I am doing this? Because I can cancel out this thing. So what is left? I have delta y upon delta x is equal to 1 upon delta x twice cos x plus delta x by 2 and then sine delta x by 2. Right? So I'll just rub this off from this side. I'll just rub this off. Now, I'm done till here. It's delta y upon delta x. If we remember our previous question, so what was the next thing? It was the limits. So what I'm doing, I'm applying limits to both sides. So it is limit delta x tends to 0, delta y upon delta x is equal to limit delta x tends to 0 twice cos x plus delta x by 2 sine delta x by 2. But I just forgot one thing, that is delta x, which is in the denominator part. So I will take the delta x and I will write it here. Now why I am writing, there is a reason. After this part I'll just let you know. I am just putting a 2 here by myself, and this 2 is extra, so I will put a 2 here as well. If we see, if we cancel out this 2 and this 2, it becomes the same thing what I had earlier. But now this 2 I will cancel out with this, and now what I'm having again, I'll repeat it again. It's delta x tends to 0, delta y upon delta x limit delta x tends to 0. Now I have cos x plus delta x by 2, then sine delta x by 2, and again delta x by 2. Now concentrate on this part. We have limit, we have sine, we have delta x upon 2, delta x upon 2. So we have a small formula here. We say we know that limit delta x tends to 0, sine delta x upon delta x, it becomes 1. So if we have delta x as theta for sine and the same delta x is down also, it doesn't matter if it is in delta or not in delta form, so it can be x also, but the denominator and the numerator, the theta and the numerator, they should be same, it becomes 1. So now this thing, as I told you earlier also, this becomes dy upon dx, and now limit delta x tends to 0, cos x plus delta x by 2, this whole thing, because of the limit and the same numerator and denominator, becomes 1. Now dy upon dx is equal to, if I apply limit, it becomes cos x plus 0 upon 2. And now what is left? It is d upon dx. Why was sine x is equal to cos x plus 0 upon 2 becomes 0, it remains cos x. So differentiation of sine x becomes cos x. Is that clear? If you have any doubts, you can definitely message me, you can write a message and let me know. I will clear that doubt for you. So I hope this is clear to you. Now I will go for the next one. After sine x, we have another one. What that one is? Obviously that is cos x. So we'll just solve cos x also using the same method. We will just make sure that we are good enough in differentiation. So now it is y is equal to cos x. So by now you must remember this is our first equation, giving small increment to both sides. Y plus delta y is equal to cos x plus delta x. This is our second. Now subtracting first and second, we get, what are we getting? It is y plus delta y minus y is equal to cos x plus delta x minus cos x, right? Same thing, y and y goes, delta y is equal to cos x plus delta x minus cos x. It's clear till now? Again, if you see in our previous question, we had sine, we took this as a minus sine b. Now we have cos a minus cos b. So again we have a trigonometric formula. We know that cos a minus cos b is equal to minus twice, it is twice sine a plus b upon 2. Then we have sine a minus b upon 2, right? So there's a small difference here with the formula. The sine was different and the cos is different now. So we will use, this is a negative, mind you, this is the negative one. So we will use the same one. So it is delta y is equal to, this is cos a minus cos b. It becomes minus twice sine. We have a plus b, that is x plus delta x plus x upon 2. And then we have sine a minus b, sine x plus delta x minus x upon 2. Right? So delta y minus twice sine, it is 2x plus delta x upon 2. Then this and this goes, it is sine delta x upon 2. Now I'll just bifurcate it here itself. Delta y is equal to minus twice sine 2x upon 2 plus delta x upon 2, then sine delta x upon 2. This and this 2 and this 2 is gone. So we have this thing. Now we will divide both sides by delta x. So what we have, delta y upon delta x is equal to 1 upon delta x. Then we have minus twice sine x plus delta x by 2, and then sine delta x by 2. Right? Now you must remember, next part or the next thing is applying limits. So applying limits to both sides. It is limit delta x tends to 0, delta y upon delta x, limit delta x tends to 0, 1 upon delta x, minus twice sine x plus delta x by 2 and sine delta x by 2. Right? So we have applied the limits. I'll just rub this side so that I can write the rest of it. It's very easy, just need to practice. Okay, so now this whole thing becomes dy upon dx, and we'll just do one more thing. Before this, we will use the formula. I'll say we know that limit x tends to 0 sine x upon x is equal to 1. So limit delta x tends to 0, delta y upon delta x is equal to limit delta x tends to 0. Now this delta x, I'll take it all the way to sine delta x upon 2. So this becomes minus twice sine x plus delta x by 2, then sine delta x by 2. The delta x in the denominator, it comes here. I'll put another 2 and 1 2 in the numerator. We'll cancel this. Now this becomes dy upon dx. Now what we have here, it is limit delta x tends to 0 minus sine x plus delta x upon 2. This whole thing, because of this formula, is 1. So we don't need to write that. So d upon dx, y was cos x, is equal to minus sine x plus, if I apply delta x 0, it becomes 0 upon 2. So we have d upon dx of cos x equal to minus sine x. Right? So this is how we use ab initio method when it comes to differentiation. We have many more questions to do as well, but I don't want to make this video too long. We will continue this and we will do the rest of the questions in our next video. In case if you have any doubts, if you have any problems, you are not able to understand any part of it, please message me. I will definitely revert back to you. Keep liking our videos, keep subscribing, and we will definitely help you for your educational purpose. We will help you in all the subjects. It's not just the maths. We will help you in other subjects as well. So thank you so much for watching my video, and thank you so much, and Happy New Year to all of you. Thanks a lot.